Last mandatory video for math. Can't believe we've made it. So in this video, I just want to give you a little bit of an overview for the final summative, what I'm looking for, what to expect. So that way you just make one submission. It's so awesome that I'm just like, here's your 100. Thank you for stopping by, kind of thing. That's what I'm expecting because I know you guys are capable of this. And if not, we can work on this, okay? So for the summative, it's just going to be 3 questions. And for each question, the basic overall idea is you make a problem and you kind of solve it. But you're not just making any problem. I'm giving you certain guidelines for what your problem should include. So these guidelines are, I'm telling you what your answers to the problem should be. And I'm telling you that in order to solve it, a person should have to use certain identities in order to obtain the solution. So I would highly recommend that you go back and look at the work that you've done this week to help you create a problem, because essentially I'm asking you to kind of go in reverse, right? For all the work that you've done this week, you figured out what the answers were, and you've had to use certain identities to get there. So build it back up to where you started based off whatever I give you. Once you wrap your head around that and you think about it a little, just it shouldn't be that bad. You just have to make sure that you format things properly so that you can use a substitution for an identity. Okay? If you can do that, then you're pretty much there. Aside from that, since I have 3 problems, I'm going to ask you to record a video for number 1 and for number 2. So I want to see your thought process for, based off what I gave you, how did you come up with the original problem, so to speak? So in that, I'm gonna go ahead and give you an example of what I am looking for, because I think that is very useful to you guys. All right. And hopefully when I go through this, I can show you some things to help you get started. Because since I'm giving you the solutions you should get, that means that you have to undo what I did to get my solutions. So you have to figure out if we were using a sine or a cosine, and then from there, kind of work your way back. All right. So I'll show you a very specific example that is not on par with what you guys are going to do. It's a very simple example to show you the kinds of explanations I'm looking for and some of the thought process you should consider as you're solving this. So let's say that I'm required to use a reciprocal identity, and the solutions are pi over 2 plus 2n pi and 3 pi over 2 plus 2n pi. Okay? So this is the bare minimum for what you have to, what I'm looking for. The first thing I want to make sure you note is you need to figure out, are you using sine, are you using cosine, what are you doing? So I would say look at the given solutions, the principal angles I have, and consider where would I have gotten these solutions from. So this is where you want to access your knowledge of the unit circle to really show me how well you understand that. Because if I look at pi over 2 and 3 pi over 2, well, I know sine of each of those values. One is a positive one is a negative one. So it is possible that, yeah, it could be positive one, negative one. But I'm going to keep it simple and I'm going to say, well, the signs are different, but one's positive, one's negative, so they're kind of close. But the cosines are exactly the same, right? Cosine pi over 2 and cosine 3 pi over 2, they're both equal to 0. So if I'm going to keep it simple, I'm just going to go ahead and stick with cosine. So that means I would have had to solve cosine of x is equal to 0. Because cosine of x equals 0 produces these given answers because, and again, this is what I'm looking for in the video. I know cosine of pi over 2 is the same as cosine of 3 pi over 2. All right, so that explains my choice of the cosine. And then from there, it says I need to use the reciprocal identity. So I could at this point employ it and say from here, secant of x would have to equal undefined. And I'd have to explain, well, why am I using a reciprocal identity? Because I have it there. They're telling me to use a reciprocal identity. I don't have to make this overly complicated. I can just go ahead and take the reciprocal of that second to last step. So this could be like a two-step problem, and I can be done, right? So from here, I can be like, okay, well, it meets the requirements. Or I think it meets the requirements, right? I'm using secant because secant is the reciprocal of cosine, and I got undefined because the reciprocal of 0, I can think about the 0 as 1 over 0 over 1. So then when I flip it, it becomes 1 over 0, which is actually known as undefined. That's why I do that here. That's why it has to be equal to an undefined value. So bare minimum, that could be a problem that works as long as you also check yourself. So at this point, if you say this is the original problem, so call it OP, then you need to make sure that secant of pi over 2 will be undefined. And you want to make sure that secant of 3 pi over 2 is also undefined. So you need to show those calculations. So if I was doing that, I would say, okay, well, I can think of this as 1 over cosine of pi over 2, which would mean it's 1 over 0, which would actually be undefined. This would be 1 over cosine of 3 pi over 2, which is equal to 1 over 0, which is also undefined. Through that right there, I used a reciprocal identity, right? Because I converted secants back into cosine form in order to evaluate it. And I have it there. So, because I have to make sure that I have a 0 in my denominator in order for this to be identified. So that's where I can get the cosine of x is equal to 0. That's the checking, because again, you're talking about solving it as if you did it for the first time. Hopefully that made sense, because it's not just like checking your answers, but like making sure that the steps are there. So that's one way you could do it. However, you could have also gotten fancy, right? This orange is the bare minimum, but if I wanted to, I could have squared this right here, I could have had this secant is the same as, or secant squared is the same as 1 plus tangent squared. So I could have asked for 1 plus tangent squared of x is equal to undefined. Right. So if the black is my original problem, one, it uses a Pythagorean identity because then I would convert this into a secant squared. And then my solving gets a little harder because now I have to go ahead and square root. Square root of undefined is still undefined because I don't know what that comes out to. So I'm trying to figure out where secant of x would be undefined, which means I want 1 over cosine of x to be undefined. And I know that something is undefined if it comes from a fraction. If I write this as 1 over 0, let's say, because if I have a common numerator, then I can work that, and then I can just take the reciprocal here and say cosine of x equals 0, and I get my answers. So when you record your videos, you can do it one of two ways. Show me the thought process for how you created the original problem like I did, or show me the end game, like show me the original problem that you created, walk me through how you solved it, and show me that you're actually using the identities you're supposed to as you go along. So, like what you guys have been doing regularly for your videos. So you have two different ways that you can achieve the same goal. Start at the beginning, show me a thought process for how you work backwards, and then just verify your solutions, or show me the end product that you made, solve it, showing me that you're using each of the required identities along the way. And if you can get me the solutions I gave you, then that's good too. Hopefully this has been helpful in terms of what I'm looking for. And again, I believe the biggest stumbling block that you guys are going to encounter to begin with is how to use the solutions. So when it comes to the solutions, think about, are you going to use sine or are you going to use cosine? In the problems that I give you, it should be one or the other. It should not require you to think, oh, well, it could be a sine, or oh, it could be a cosine. Like, you're going to have to make a choice at the beginning and then transform your way through. Okay? You can add or subtract stuff, anything you want algebraically, as long as you do it evenly to both sides, and as long as you check your work to make sure that the solutions do play out the way they're supposed to, you should be good for this. And again, office hours Friday, office hours Monday. If you need to talk stuff out, if you feel like this is not going to go well, I can talk you off the edge. I believe you guys are competent. I believe you guys can do this. I believe you guys have been doing pretty well overall for the remote learning. I cannot tell you I can't stop saying how much I admire how some of you guys really excelled during this right here, because I don't think I could have done what some of you guys did, and I really respect you for that, and I really admire the consistency that you guys have been putting forth. So thank you for this experience. I know it's not ideal. I honestly do appreciate it.